everyone, today we will continue to the subtopic 3.2, differentiation of logarithmic function. Subtopic 3.2, differentiation of logarithmic function. Course framework. A. Differentiate of logarithmic function. We will use the chain rule to differentiate fx equals ln ux and also include differentiation of the combination of exponential and logarithmic function. Differentiate of logarithmic function. If y equal to the ln fx, then dy dx equal to the f prime x over fx. We prove that let u equal to the fx, du dx equal to the f prime x. So y equal ln u, then dy du equal to the 1 over u. Next, by using chain rule, we have dy dx equal dy du times du dx. Then we replace that dy du is 1 over u. Then du dx is f prime x. Thus, dy dx equal f prime x over fx. Fx equal ln x is differentiable for all x greater than 0 with d dx ln x equal 1 over x. Natural logarithmic function of the form y equal ln fx, where fx is a linear differentiable function of x, can be differentiated as d dx ln fx equal f prime x over fx. Properties. The first one is d dx ln x is equal to the 1 over x. Number 2 is d dx ln u is equal to the 1 over u du dx, whereas u is equal to the fx. Then we can use this formula, d dx ln fx is equal to the 1 over fx, and then now we differentiate fx, we can get fx. So the answer is f prime x over fx. The third one is d dx log x base a is equal to the 1 over x ln a, and the last one is d dx log u base a is equal to the 1 over u ln a du dx, where u is equal to the fx. Example 1. Differentiate the following with respect to x. A. Ln for x. B. Ln x squared plus 3x minus 1. By using this formula, d dx ln fx equal to the f prime x over fx. The first step is, if we look at for the ln fx, we copy fx here and then we put to the bottom. Now we differentiate fx, we put to the top here. So now we differentiate ln fx. We have d dx ln fx. Now we copy for x here, we put to the bottom. Then we differentiate for x, we get 4. Then we simplify, we have 1 over x. B. Ln x squared plus 3x minus 1. The same one, we want to differentiate this one, we put d dx ln x squared plus 3x minus 1. All function in bracket here, we put to the bottom. Then we differentiate here, we get 2x plus 3. Example 1c, y equal 4 ln x squared plus 3. If we differentiate dy dx equal to the 4 is a constant, we just take out here. Then we put x squared plus 3 to the bottom. We differentiate x squared plus 3. We have 2x. Then we simplify until we get 8x over x squared plus 3. Example 1D, y equal ln to x to the power of 5. By using this formula, we differentiate dy dx, the first one, by taking 2x to the power of 5, we put to the bottom. Then we differentiate 2x to the power of 5, we put to the top, until we get the answer is equal to the 5 over x. However, we have alternative method, that is y equal to the ln to x to the power of 5. We can use law of log. We split ln to x to the power of 5 until we get ln 2 plus 5 ln x. Then we differentiate 1 by 1. Ln 2, we differentiate, we get 0, which is ln 2 is a constant. Then we differentiate 5 ln x, we get 5 over x. Example 2, differentiate the following with respect to x. Y equal to the ln for x to the power of 4. Let u equal to the ln for x. If we differentiate, du dx equal to the 4 over 4x. And then we have 1 over x. Thus, y equal to the u to the power of 4. Now we differentiate y equal to the u to the power of 4 using power rule until we have 4u to the power of 3. Then by using chain rule, we substitute dy du times du dx. So we have 4u to the power of 3 times 1 over x. Then we replace u is equal to the ln for x here. Then we have 4 over x ln for x to the power of 3. Example 2b, fx equal to the ln square root of x plus 1. For this example, we use law of log. Okay, square root of x plus 1, we can change to the 1 over 2 ln x plus 1. Then directly we differentiate, we have 1 over 2 times 1 over x plus 1. We simplify until we have 1 over 2x plus 1. Example 3. Find the derivative of the following. Y equal to the x ln x, and d is y equal to the ln x over e to the power of x. Example 3a, y equal to the x ln x. For this question, we differentiate by using product rule. That is, differentiate y, we get dy dx. For this case, we divide by two functions. That is, if we taking x and then we differentiate d dx ln x. If we taking ln x and then we differentiate d dx x, or similarly, we use product rule. d dx uv is equal to the uv prime plus vu prime. That is, we let that x is equal to u, and then we let that ln x is equal to v. Then we differentiate, u is equal to x, and then u prime is equal to 1. Then v is equal to the ln x, v prime is equal to the 1 over x. Okay, now we simplify and then we put into this equation. So we have that x times 1 over x plus ln x times 1. Then we solve for this example, we get 1 plus ln x. Example 3b, y equal to the ln x over es. For this question, we use quotient rule formula, that is dy dx, and then by taking ex, now we differentiate d dx ln x, always minus here, and then by taking ln x, and then we differentiate d dx ex, then we have to divide by ex to the power of 2. Similarly, if we use this formula, d dx u over v is equal to the vu prime minus uv prime over v square, which is we let that u is equal to the ln x, and then we let that v is equal to the e to the power of x. Now we have that this one, then we minus this one, then we substitute to this formula, then we have that 1 over x times ex minus ln x times ex over ex to the power of 2. Now we simplify until we get 1 over ex times 1 over x minus ln x. Example 4. Find the derivative of the following. A. Y is equal to the ln e to the power of 2x times 3x squared minus x. And B is y equal to the ln in bracket 1 minus x squared over square root of 2x plus 3. Solution for example 4a, y equal to the ln e to the power of 2x times 3x squared minus x. For this question, we will use law of logarithm, that is, log ab is equal to the log a plus log b, or if we have ln ab, also the answer is ln a plus ln b, and also we use law of logarithm, ln ex is equal to the x. For this question, we split this one, then this one is multiplied, then we change to plus here using law of logarithm. Then we have that ln ex here, we change to this formula, ln ex is equal to x, until we get y is equal to the 2x plus ln 3x squared minus x. Now we differentiate, so we have that dy dx equal to the 2 plus 6x minus 1 over 3x squared minus x. Then we simplify until we get the answer is 6x squared plus 4x minus 1 over x times 3x minus 1. Solution for example 4b, y equal to the ln 1 minus x squared over square root of 2x plus 3. For this question also we use law of logarithm, that is ln a over b is equal to the ln a minus ln b, and also we use ln a to the power of n is equal to the n ln a. Now we split to two functions, ln 1 minus x squared minus, divide here we change to minus, 1 over 2 is a square root, ln 2x plus 2. Now we start differentiate y with respect to x, so we have that dy dx equal to the 1 minus x, we put to the bottom, and then we differentiate 1 minus x squared, we have negative 2x, and then minus 1 over 2 is a constant. Also differentiate ln 2x plus 3, we put 2x plus 3 to the bottom, and then differentiate 2x plus 3, we put to the top. Then we simplify this question until we get negative 3x squared minus 6x minus 1 over x squared 3x minus 1. To make sure that you understand for this subtopic, make sure that you do all the exercises here. Okay, that's all. Be right back.